One of the biggest mysteries in astronomy is the constant detection of strange radio signals from space. So far, scientists have been unable to prove what causes these mysterious phenomena, and one of the most prevalent theories is that these signals may be messages from an alien intelligence trying to contact us here on Earth. There are many observatories dotted around the globe with the sole purpose of trying to detect and understand these signals better. Recent reports state that one such observatory has detected a strange new radio signal which mimics the sound of a heartbeat. Let's take a closer look at this latest discovery. Fast radio bursts, or FRBs, are super intense, millisecond-long bursts of radio waves produced by unidentified sources in the distant cosmos. Their discovery in 2007 by American astronomer Duncan Lorimer led to the term Lorimer bursts. Since then, just a few dozen similar events have been observed in data collected by radio telescopes around the world, building evidence that points to a variety of potential causes. Only a handful of emissions have been traced to specific areas of the sky, most indicating sources in other galaxies. In 2020, a source within the Milky Way, most likely belonging to a type of neutron star called a magnetar, was confirmed to be a fast radio burst emitter. The flash of radio waves is incredibly bright if distant, comparable to the power released by hundreds of millions of suns in just a few milliseconds. This intensity suggests powerful objects like black holes and neutron stars could be involved, with highly dense bodies such as magnetars and pulsars as likely culprits. The events were once considered to be largely transient. They seemed to happen once, without obvious signs of a repeat emission. It was only in 2016 that astronomers found any evidence of multiple bursts from the same source. Several repeaters have been identified since then, with some researchers venturing that many, if not all FRB sources, could routinely emit bursts in sequences too difficult to detect using current instruments. The hypothesis was supported when scientists reported in a discovery in 2020 that an FRB observed 3 years previously had since repeated faintly on 2 more recent occasions. Shortly after this report, astronomers with the Canadian Hydrogen Intensity Mapping Experiment, or CHIME collaboration, published findings of the first FRB we know of that's repeating in a distinct pattern. The FRB has a predictable pattern of hourly activity over 4 days, followed by 12 days of quiet. With much still to learn about FRBs, their mechanism is one of the biggest mysteries in modern astronomy. New research states that rapid bursts of radio waves that originate millions to billions of light years away from Earth could be used as probes to investigate halos of difficult-to-see, diffuse gas surrounding nearby galaxies. According to the research, these radio bursts slow as they pass through the gas enveloping the galaxies between their source and Earth. This also has the effect of dispersing their radio frequencies, using this to investigate galactic gas halos. Researchers from the California Institute of Technology found twice as much material as previously believed in these envelopes that enshroud galaxies. This has implications for how these collections of stars and planets evolve over great periods. The astronomers looked at a sample of 474 distant FRBs with the Canadian Hydrogen Intensity Mapping Experiment, confirming that 24 FRBs intercepted by galactic halos were indeed slowed down compared to others that traveled to Earth unimpeded. Thus, this effect can be used to probe the material through which the FRB passes. The use of more distant FRBs from outside our galaxy to investigate the massive pools of gas that surround other galaxies has already revealed a surprise. The astronomers found that there is more matter in gas halos than previously believed, around twice as much as predicted by the theoretical models. Because these gas halos are the remains of the same material that is used to form the stars and planets, a deeper investigation of them could lead to a better understanding of how galaxies evolve over periods of billions of years. Though researchers aren't currently certain of the origins of FRBs, they believe that these pulses of electromagnetic radiation, lasting from a fraction of a millisecond to a few milliseconds, are emitted by rapidly rotating magnetic dead stars called magnetars. Evidence of this connection was provided in 2020 when Caltech's survey for Transient Astronomical Radio Emission 2, or STARE-2, instrument was teamed with CHIME to detect a massive FRB erupting in the Milky Way. Since their discovery in 2007, hundreds of FRBs have been observed, and these revelations are expected to continue rolling in thanks, in part, to Caltech's 110-dish Deep Hypnotic Array, or DSA-110. The project's already identified several FRBs and traced them back to the galaxies from which they originated. Caltech scientists have plans to build an even larger telescope array over the coming years, which will consist of 2,000 dishes. Named DSA SA-2000, the project will be the most powerful radio observatory ever built and could detect and identify thousands of FRBs and their sources each year. There are many theories about what the cause of these radio signals may be. One theory is that they may originate from a rapidly spinning neutron star. When stars explode and die, they can end up as rapidly spinning neutron stars. Astronomers think those found in a region with a high magnetic field might produce these strange signals. Two neutron stars colliding with each other is another possibility. However, this scenario only works for cosmic signals that are only seen once, as the stars are destroyed in the process. Most of the fast radio bursts picked up by telescopes in the last decade or so are seen once and then disappear. Yet two elusive signals have been found that burst to life again and again, and for these, there must be a different explanation. Another explanation may be a blitzar. It's a rapidly spinning neutron star that collapses under its own weight and forms a black hole. Again, this ends in the destruction of the star, so it could not produce a repeating signal. Black holes are implicated in many theories, from a neutron star falling into a black hole to a collapsing black hole or dark matter hitting one. While some believe the signals are entirely natural in origin, others have speculated that they could be evidence of extraterrestrial activity. A few months ago, it was reported that an international team of astronomers discovered a second persistently active fast radio burst, posing questions about the nature of the mysterious phenomena. The news source, Fast Radio Burst 201-90520b, was initially detected with the 500-meter Aperture Spherical Radio Telescope, or FAST, in Guizhou, China on May 20, 2019, and found in data in November that year. Follow-up observations by the Jansky Very Large Array program led by Caltech found weaker, constant radio emissions associated with the FRB, also allowing the Subaru telescope in Hawaii to localize the source to be within the fringes of a dwarf galaxy nearly 3 billion light-years from Earth. The biggest surprise of this discovery for scientists was that the new FRB seemed to be a perfect twin to an earlier discovery. Many believe that the first such association between an FRB and a radio source may have been a coincidence because it was hard to explain. However, the newer second example shows that it may be a real and critical part of the life of an FRB. The discovery raises new questions about the nature of FRBs, such as if the sources of the FRBs evolve, or whether different kinds of sources are capable of emitting FRBs. One of the key questions in the field of FRBs is whether all FRB sources repeat. Scientists favor the theory that if all sources do repeat, their activity levels drop precipitously as the source ages. Since FRB 201-90520b is only the second of around 500 known FRBs to have a so-called PRS counterpart, and both are extremely active, they could, hypothetically, represent the youth of the radio burst. Another special feature of FRB 190520b is its dispersion measurement, which indicates its emissions pass through the highest density of electrons of any FRB before being observed on Earth. This suggests the FRB is active in a local plasma environment, such as that created by a supernova, and is a newly created source. While providing insights into the environment of FRB 190520b, the large disparity in dispersion measurements with other FRBs calls into question their use as cosmic yardsticks for measuring distances. Scientists say that an evolutionary path for FRBs is possible, but with just two sources it is hard to tell. We need to find more data and constrain this evolutionary stage model. We need more signals at a different age to prove that the burst is fading away all the time. Cooperation between astronomers and facilities across the globe will be crucial in finding, localizing, and characterizing these mysterious phenomena, as it has been the case of FRB 190520b. More recently, astronomers at the Massachusetts Institute of Technology have picked up repetitive radio signals from a galaxy billions of light-years from Earth. Scientists have not been able to pinpoint the exact location of the radio waves yet, but suspect the source could be neutron stars, which are made from collapsed cores of giant stars. The signals have been occurring steadily and last up to 3 seconds. Most fast radio bursts, or FRBs, only last a few milliseconds. The report states that within this window, the team detected bursts of radio waves that repeat every 0.2 seconds in a clear periodic pattern, similar to a beating heart. On December 21, 2019, researchers at the Dominion Radio Astrophysical Observatory in British Columbia, Canada, picked up a signal of a potential FRB. Not only was it very long, lasting about 3 seconds, but there were periodic peaks that were remarkably precise, emitting every fraction of a second. This is the first time the signal itself is periodic. Data on the burst, including their frequency and how they change based on where the source is located in proximity to Earth, could help researchers determine at what speed the universe is expanding. Most FRBs, which are strong bursts of radio waves from galaxies billions of light years away, last just a few milliseconds before blinking out and are one-off events. This new signal, FRB 2019-1221A, lasts up to 3 seconds, making it 1,000 times longer than the average FRB, and also has the clearest repeated pattern discovered thus far. Going forward, the researchers will attempt to catch further bursts from the same source that could help to more conclusively reveal what is causing these FRBs. The signal FRB 2019-1221A was first detected by CHIME on December 21, 2019, and its unusual nature was immediately spotted by scientists. When the researchers from MIT analyzed the pattern of this signal from a distant galaxy, they found similarities with emissions from radio pulsars and magnetars closer to home in the Milky Way. There is one key difference between FRB 2019-1221A and signals from these objects within our galaxy, however. The former is over 1 million times brighter than the latter. Scientists believe that the highly luminous flashes of FRB 2019-1221A could indicate that the radio pulsar or magnetar emitting them is usually much less bright. This could mean that some unknown mechanism or event has caused it to emit a train of brilliant bursts in an unusual 3-second window. CHIME continuously scans the sky over Earth as our planet rotates and is fortunately positioned just right to catch this rare burst. The instrument, an interferometric radio telescope made up of 4 large parabolic reflectors, is no stranger to spotting FRBs. Since it commenced operations in 2018, it has spotted hundreds of these bursts. Astronomers hope that future telescopes will detect thousands more FRBs each month, and periodic signals like FRB 2019-1221A could be amongst them. If you found the video informative, please consider checking out this one, which talks about the James Webb Telescope's terrifying discovery at the edge of the universe. Do you think fast radio bursts are signals from an alien civilization? Please share your thoughts in the comments section below.